Okay, so let's look if it's recording now. Yes. Okay, so let's look at this concept. A lot of students keep asking me about the equation to model the air pollution. I know that if you live close to a refinery, or if you live close to a company, or if you live, like for example, in Amghara, if you live in Al Ahmadi, of course you would be expected to get some pollution from the refinery. If you live in Slaybahat, or if you live in Jabr al Ahmed, these cities, Doha Sharqiya and Doha Al Gharbiya, Doha East and Doha West. So you would expect to have the pollution. Of course, we did talk about the chimney height and the extra delta H, the bloom height, and the big H. And we are always measuring on in the center line of the bloom, of course. In this class, and this is also very important, we will be dealing with people in ground. We're not going to be talking about people who are living at 5 floors up or 10 floors up, so they might get the exposure of the pollution. No, we will deal only with the modification of the equation for ground level. That's it. So which means that Z is equal to 0. And also, I don't care about the neighbors. I'm dealing with one person now. So I'm going to make also Y equal to 0. Just only for simplification. I want it in ground, and I don't want the neighbors. I want this house. Cross in the x-axis. Okay, in the x-axis, center line. So this is the equation. Let me just go to the equation. I'll come to this. I'll come to this table in a few seconds. This is the equation that will find out for us the concentration of the pollutant at the x-axis. Again, I'm assuming that y is 0 and z is 0. This is what? This is S. And that is how much is the source coming up. If I give it to you in kilogram per day, let's say the source in kilogram per day, you have to convert it to kilogram per second. Because here we're going to have velocity, wind velocity here. And that's going to be meter per second. And everything else is in meter per second. So please change this to kilogram per second. Do not just put kilogram per day and then get the wrong number. Kilogram per second, put it in S. You have 2. You have pi. We know pi is constant, 3.14. Okay. You have velocity, wind velocity, of course. Sigma y, sigma z. Now, sigma y and sigma z, how could we find sigma y and sigma z? Don't worry about this graph because the table will give you accurate results. So I don't have to worry about this. Let me see how could I find out sigma y and sigma z. I'll tell you that the wind speed at 10 meter is 2.5 meter per second. So I say that the velocity is 2.5 meter per second. And I'll tell you about the stability of the air around us. It's slight, for example, and in daytime isolation. So if I say that 2.5 slight daytime isolation, I mean class C. If I say, okay, it's 5.2 meter per second at 10 meter, this is the wind speed, and it's a nighttime cloudness, and it is less than or equal 3/8 cloudness. So which means it's class D. You have to get the class from this table. I will give you the description of the atmosphere. Of course, the stability of the air today is not like the stability of the air yesterday. Stability keep changes with time. In the morning, different than the noon, different than the night. So now once we get the class, we could go to this table. And now in the problem, I'll tell you, is it either open country? Are you in the farm? Are you in the desert? Or it's an urban condition. Are you in Khaldiya? Are you in Adeliya? Are you in Junub Surah? Something like this. Urban condition, between houses, within the blocks, okay? Okay? Open country, you are in the farm, big, huge area, open area. So what was the classes we have? Let's take class C. Okay, let's take class C. And let's assume it's an urban condition. It's a Khaldiya. We are in Khaldiya. Class C, so this is sigma y, and x is the distance from the chimney in the x-axis, straight line. We are not going y, we're not going up z, only in the x-axis. And I'll give you the distance x. Okay, and also 0.2x sigma z, x would be given to you. So now we find x sigma z. We could go and plug in the number. I mentioned here that y is 0, so this is going to be 0, so the whole thing going to be 1. And I mentioned also that z is 0, so this is going to be good in the ground. So now we're going to have minus s. This is the height of the chimney. The height of the chimney. Sigma z square, of course, both. And then you can find out the concentration of the air. What will happen if I give you the concentration of the air? You could find the height of the chimney. Okay. Sometimes the Environmental Protection Agency, based on the air pollutants, they will determine what will be the minimum height of stacks, minimum height of chimneys. Of course, now, if you plug in the number as usual, meter per second, and S is kilogram per second, what will be the concentration? The concentration will be in kilogram per meter cube. Okay, and if you plug in everything in as is, kilogram per second, and everything else meter per second, and the rest as is, meters and everything else. Let's say that if I want to find it in microgram per meter cube, if I give it to you in microgram per meter cube, so kilogram per meter cube, kilogram to gram, gram to microgram, like this. So you could convert kilogram per meter cube to microgram per meter cube. Okay, so I think that this is it for this explanation, and inshallah, this is going to be the best presentation to get 100% on this question. Thank you.